Hello, today we will understand cloud computing, model service security, infrastructure security, PaaS security, and SaaS security models. So we'll start with the infrastructure security model. So there are many components that we need to secure in IaaS security model, like all the underlying infrastructure that IaaS service provider provides, CSPs provide, that the main components are hypervisor security, VM security, virtual switch security, virtual storage security. All these four major components of underlying infrastructure that CSPs, IaaS providers or CSPs like Amazon and Azure is providing to their customers. So we need to make sure that hypervisor, VMs, switch, network, storage, everything is secure from these major attacks. So let's start with the hypervisor security attacks. We need to we need to make sure that hypervisor should be secure from hyperjacking, blue pill, vitriol, and DKSM. Hyperjacking means installing a rogue hypervisor that can take complete control over the server, such as subware. Subware is an example of hyperjacking. Blue pill. Blue pill is nothing but a hypervisor rootkit using AMD secure virtual machine. This is also one type of hypervisor attack. And another is vitriol, that is hypervisor rootkit using Intel VTX, and another one is DKSM, direct kernel structure manipulation. So that manipulates the kernel level of hypervisor, that increases the attack surface of the hypervisor. So we need to make sure that malicious hackers should not uh, should not impact hypervisor as a whole, because malicious hackers consider hypervisor as a potential target to attack because hypervisor enables control over the installed VMs, physical systems, and hosted applications. So malicious users is having high confidence and high attack surface vector on hypervisor. So hypervisor security is a very important part of infrastructure security. And VM security. Next is VM security. VM security is virtual machine security. There are many virtual machine attacks nowadays is happening in the cloud environment, where cloud servers contains tens of VMs, hundreds of VMs. These VMs may be active or offline, but both are vulnerable to attacks, because if offline VMs is having outdated patches, outdated antivirus, so it is more vulnerable to attacks. And virtual machine based rootkits, VMBRs. These are a VMBRs. VMBRs is the rootkits act by inserting a malicious hypervisor on the fly or modifying the installed hypervisor to gain control over the host workload. Okay, so this VMBR is also a major attack rootkit. And then is a collocation, where multiple VMs are running on a single server and sharing the same resources, increase the attack surface and the risk of VM to VM attack or VM to hypervisor attack. When you say VM to VM attack, is a VM hopping. This terminology called as a VM hopping. Okay, and next is VM escape. This is VM escape. VM escape is another common attack on the VMs, which is done by crashing the guest operating system, to get out of it and running an arbitrary code on the host OS. This allows malicious VMs to take complete control of the host operating systems. So this we need to make sure that virtual machine security is enough to secure the infrastructure security model. Next, move on to virtual security, virtual switch security. So here we have a major component like routers, switches, where virtual switch is vulnerable to wide range of layer 2 attacks like um, modification and manipulation of ARP tables, VLANs, trust, trust zones, and virtual switch configurations. So DOS attack is also happening on the external interface of virtual switch, virtual router, and other network devices. So, and next is virtual storage security, where we have data stored in a virtual environment. Unauthorized access will impact the data, and we need to make sure that encryption is enabled on the virtual storage to maintain the security in the virtual storage environment. So this is all about infrastructure as a security. Security is needed on this in this model to protect all these important components of infrastructure security. Next, we move on to PaaS security, platform as a security model, where there are four pillars. One is system and resource isolation, user level permissions, user access management, and protection against malware backdoors. System and resource isolation, here PaaS tenants should not have a cell access to their instances where they are running. It will impact the tenants, PaaS tenants, to gain more access. Suppose if any user will gain access, will have a high admin level access, root level access to one of the PaaS tenant or virtual machine. If any changes happen or any malicious code in runtime happens, it will impact other PaaS tenants. So it makes sure that careful consideration should be given before access is provided to the underlying infrastructure hosting a PaaS instance. So we should implement efficient access control to protect this PaaS resources, isolation systems. And next is the user level permissions. So user level permission, user level entitlements, network permissions. So each instance of a service should have its own notion of user level entitlements. So each instance of a service, like application running on the instance, each multiple users supporting the application, each user should have a user level permission to support that applications running on the PaaS instance, PaaS environment. One user should have admin level access, another user should have a monitoring access. So we need to maintain user level permissions on the PaaS application infrastructure as a whole. Then we move on to user access management, where user access management enables users to access IT services, resources, data, and other assets. Access management helps to protect the availability, integrity, and confidentiality of these assets and resources. So their key components of user access management are intelligence, administration, authentication, and authorization. Intelligence where requires collection, analysis, auditing, and reporting. Administration, ability to perform onboarding and offboarding the users. And authentication provide assurance and verification in real time as to user being who she claims to be. And authorization determine the level of access grant to each user based on policies, roles, rules, and attributes. So this is all about user access management. Then we have a next is we'll have a protection against malware backdoors. So in a traditional environment, developers were developing the application, leaving many backdoors in the application where attackers use these backdoors to gain access, malicious access in the application. So now in the recent world where cloud computing is having many challenges, so applications should have most recently attackers have utilized embedded and hard-coded malware as a method of obtaining unauthorized access and retaining this access for prolonged extended period. So this malware has been placed in point of sale devices, handheld handheld devices, etc. So we need to make sure that the application should be completed by full development life cycle to make sure that should not be any backdoors, malware during the development of the application in the past security. Next, we move on to the third and very important SaaS security model, where we have three components related to SaaS security model: data segregation, data access and policies, web application security. Data segregation. As you are aware of, multi-tenancy is a major characteristics of cloud computing, where um, multiple users can store their data in the same location, in the same application that SaaS provides. So this will increase the attack surface uh, for the users, because if application execute this code without verification, there is a high potential of success for the attacker to access or view other customers or tenants data. So data segregation is very important in the multi-tenant environment of a cloud computing. Then we have a data access policies. Data access policies um, where data when allowing and reviewing the access to customer data, right? So approach begins with the correct identification, customization, implementation, repeated assessments. So the cloud must adhere to these security policies to avoid intrusion or unauthorized users viewing or accessing data. So data access and policies. What data is accessing, what policies are implementing as per the users. We need to make sure that this should be a cloud must adhere to these security policies. And next is security vulnerabilities. Web application security, where security vulnerability in traditional environment you see security vulnerabilities are more common in web application security, but in the cloud environment where large volume of shared and collocated tenants within a SaaS environment, if a vulnerability is exploited, both the cloud customer and the service provider may experience a very catastrophic consequences. So cloud services rely on robust, hardened, and regular access web applications to deliver services to its users. Failure to carry out web application security assessment and code reviews may result in unauthorized access, corruption, or other integrity issues affecting the data, along with the loss of availability. So security vulnerability in application security should be controlled to get a SaaS environment more hardened, more robust. So this is all about cloud computing, three security services model, and this is all I have for today. Thanks for watching this video and hope you enjoy it. Thanks. Bye.